Okay, last section in the course, we made it. This is called the normal distribution and something called z-scores. The normal distribution around a central value dropping off symmetrically to the right and left, forming a bell shape. So when you get to university or college, oftentimes they will bell curve the marks. So it just looks something like this. Kind of like the bell. If you were to connect the bottom, it looks kind of like the Liberty Bell. So they want marks, low marks, only a few of them, most marks being in the center, and a few marks being really at the high end of things. So this is known as a bell curve. You may experience this later on in your career. Okay, so Fruity Fizz labels their bottles as 500 mils, but the system is imperfect. So the table shows the frequency distribution for 200 bottles. Okay, so the frequency of it happening, these are all out of 200. So to get relative frequency, you just divide it out. For instance, there was 2 bottles that came in between 494 and 496. That's a 1% or 0.10 relative frequency. And all of them are going to add up to 100%. Okay, in these 200 bottles. So what is the probability that a given bottle will contain less than 500 mils? So you take all the relative, there's 2 ways to do this, but if you take all the relative frequencies under 200 mils, which is these 3, add them up, you get a 28% chance. Okay, the other way is you can just, if you didn't do the relative frequency, you can just count up. Well, there's 2 bottles, 11 bottles, 43 bottles. That's a total of 56 bottles that came in under 500 mils, and 56 out of 200 gets you your 28%. Okay, works the same way. What is the probability that a given bottle will be contained between 498 and 502? So 498 and 502 are these 2 right here. Add them up, and 62% chance. Okay, so that's from that. When you go to the next question, a spot landing contest, the landing zone is 30 meters long with the target line at the 15-meter mark halfway. The table shows the touchdown positions of the aircraft along the landing zone. The data is expected to follow a normal distribution. So they land, it marks with the pieces, I don't know, they measure it, and these are all the data, okay? Pieces of data. So determine the mean and the standard deviation. So you may have to go back into your earlier standard deviation situation, but the mean, when I added them all up and divided by the 40 values, the mean was 14.63. Then you have to go and take each one minus the mean, square it, and add up all those sums. When you do that and square root it and do the n minus 1 at the bottom, you get a standard deviation of 3.259 meters. Okay, so you may need to go back and check how to do your standard deviation. That should take you a little bit of time. So from this information, I have the mean and the standard deviation. What is the z-score for a pilot that lands her plane at 18.3 meters? So you'll remember the z-score formula is you take the value that they got, 18.3, minus the mean divided by the standard deviation. You get a z-score of 1.12. Okay, so that's the z-score. So now I'm going to introduce you to something called the z-score table. It's found on page 480 of your textbook. Okay, and it actually gives you, so once you get a z-score, which we talked about earlier in the course, you can actually get the probability of getting that situation. Okay, so what's the probability that a pilot lands at a position of 18.3, or less? So at a z-score of 112. So we're going to look for a z-score of 112. So when I go to my probability, okay, so I'm looking for a z-score of 1.12. So let me show you how that works. So we look for 1.1, and I need 1.12. So as I go over, I get 86.86%. Okay, so that's how many, that is the probability of getting lower. So if that's a z-score of 1.12 there, that's how many percentages, how much percent is under that side of the curve. Okay, so you just locate it, and that is the meaning of what probability is lower than that z-score. Okay, so that's how the z-score table works. Let's try another one. what is the probability that the pilot lands 18.3 meters or more? So because the probability is 100% total, if you minus the one that's under the curve, what's left over is 13% that's on this side of the curve. Okay, and what is the probability that the pilot lands between 12.2 meters and 18.3 meters? Okay, in between those two. So I get the two z-scores, 0.75, and I already got the z-score as 1.12 for the second one. Okay, so I'm gonna look at what the probability is from negative 0.75. So when I do that, I go to negative 0.7, negative 0.75 is 22.66%. Okay, so what that means is a negative z-score would land, let's say, somewhere right here. So 22, if the dotted line was here instead, 22% of the data lies on this side of it. Okay, so what I'm looking for is what is the percentage or the probability of negative 0.5 and 1.12, the pieces in the middle. So what I do, if I go back to my calculation here, sorry. Okay, so the probability of it being less than 18.3 was 86%. And if you subtract the probability of it being less than 12.2 or 22%, those had in common, the middle ground is 64%. Okay, so if you take the 86% and the 22% and subtract them, the space in between is 64%. So that's how you would get the probability of landing those scores. Okay, so the z-score table is very helpful to get probabilities once you have a z-score. Okay, so try this out, page 341, 1, 2, 5 AD, 10, 12, and 13. And once that's done, submit it as a package, and then we'll talk about CPT next week. Thanks, guys. Hope you're all doing well, and talk soon.